Facebook uses MapReduce to get all the mutual friends between two people and store them into a disk for future use. It is easier and cheaper. We are going to figure out how they do it. Now consider this input file. Here, 1, 2, 3, 4, and 5 are all people. 1 is a friend with 2, 3, and 4. 2 is a friend with 1, 3, 4, and 5. 3 is a friend with 1, 2, 4, and 5. 4 is a friend with 1, 2, 3, and 5. 5 is a friend with 2, 3, and 4. We are going to run a MapReduce program and find out the mutual friends between each of the individuals. This is our program. As you can see, there are three classes. There's a mapper class, a reducer class, and a driver class. So running the program, we have the output. Now when we click the output, we can see that 1 and 2 have mutual friends with 3 and 4. 1 and 3 have mutual friends with 2 and 4. 1 and 4 have mutual friends with 2 and 3, and so on and so forth. Thank you.
Hello everyone, this is team 12 and I am Sneha Mishra with my team member Aditya. We will be going with the first use case for second part of the lab assignment. The use case that we are going for is Facebook messaging, that is inbox and term search. So it is divided into 4 different parts. This video will be covering only second and third part, that is HBase implementation as well as Cassandra implementation. So initially in HBase implementation, we have created a table over here, and in that we have 2 different column families, one being the users and the others being the terms that the user input. In that column family, it has different columns inside each column families, such as in the users it will have user 1, user 2 to user n, how many ever users have replied or interacted with the particular user that we are looking for. And in the column family terms, we will have different terms which are frequently used, such as addresses, names, contact infos, zip code, such terms. Those will form different columns under column family terms. So once we have created the table with the name Facebook, we can see over here, then we started putting data into that. So in the terms and the users, there are 2 different column families, and inside that we have name, then addresses or things like that that we have mentioned earlier. Coming to that, we have started, this is the final data that has been collected for HBase, and now we'll start doing queries on different 3 different queries for that particular table. So this is the description of the table. It has column families. One is the terms and the other one is the users. So for query 1, we will do prefix filter. This is just to get the number of prefix for a row key. So if we give a row 3, that is 1 row for a particular user, then we'll get to know that what interactions and which user has interacted for that particular user. So in row 3, we can see that we have the terms contact. These are the values for the contact, and the user 2 and user 3 have been shared their contacts with this user. Next, if we do a column prefix search, so in that what we do is we want a particular user who has interacted with our user to give the details. So in this we give if user 2 as our input, so we get the output that user 2 has interacted 2 times, that is in row 2 and in row 3, and the values will be 5 and 9, that is their message IDs. Next we'll get the column count filter. So if we get 0 columns, that means we don't want any columns to be displayed. If we give column filter as 1, so just 1 column, that is terms, and in that terms address and contacts are the sub columns of that, so that only 1 column filter is displayed. If we give 2, then 2 column filters are displayed, and if 3, then 3 column filters are being displayed over here. And this is one extra query that we have done is term search. If we give the column families term search, then it gives all the details for that particular column family, as in the addresses that have been mentioned, the contacts that have been mentioned, and the names that have been mentioned in the interactions for that particular user ID. Next, when we move to Cassandra, we have created a key space named as lab1, and this is our empty table that we have created named Facebook. Now we input the data, and the final table Facebook looks like this, with different users being the columns and user ID being the rows. So now we started perform, and this is the description of the key space. Let's start performing the queries. So in the step 2, first we'll do the term search. So when I want to do a particular text search, like I live in Mission is one of the searches. If I want to go for a mission search, that is textual search, then this is the user ID. As you can see in our, there's just one user that has interacted with this particular text search. So the table returns this value. Next input, if we want to get what are the contents for a particular selected user. So if user 3, whatever contents, the textual contents of that user are, that will be the input, and we select user 3 from the Facebook table, and we get the contents, that is the interactions of that user with us. This is the output. Next will be the interaction search. So if we want to get all the interactions for a particular user ID, that is 4, then we get that this user ID has interacted from user 1, user 2, and user 3, and these are the values. So this is Aditya, how are you? Call me on this number. These are the outputs of that particular interaction search. And the rest of it will be in the report and the GitHub. Thank you.